Are you interested in simplifying the development of your Ansible playbooks for large-scale VxRail automation? Even if you're a system administrator who doesn't have advanced skills in Ansible playbook development, you can still get started effectively. There are plenty of tools to offer you support, such as our publicly available modules, playbook examples, and GenAI-based assistants, such as GitHub Copilot. Hi, welcome to this demo where we will leverage GitHub Copilot to accelerate the development of Ansible playbooks and learn VxRail automation at scale. This demo is based on a real-world customer issue where the users sought guidance on security when handling credentials. They utilized our Ansible modules and playbook samples within their extensive and distributed VxRail environment. Throughout this session, you learn how to set up your environment, take your first steps with the Copilot, use it to improve the playbooks you're working on, and learn more advanced Ansible topics. Let's get started. Similar to modules for other Dell products, the Ansible modules for Dell VxRail are accessible on Ansible Galaxy and GitHub. These modules come with comprehensive documentation and sample playbooks to illustrate their usage. For the purpose of this demonstration, we will concentrate on the System module, which acts as a wrapper for the getSystem VxRail API function. The GitHub repository includes extensive documentation for this module within the Docs folder. This documentation is in a Markdown file that provides a brief description, details on the REST API function or endpoint, available parameters, additional nodes, examples, and return values. Moreover, the Samples subfolder contains a sample playbook that demonstrates the use of a specific module. In our example, it is systeminfo.iml. For those who are not advanced Ansible playbook developers, starting with even a provided usage example might be challenging. Therefore, we will demonstrate how you can utilize GitHub Copilot as your GenAI assistant to enhance your learning experience, speed up your progress, and get answers to your questions. First, it is essential to set up your development environment. Visual Studio Code is a widely used and free code editor that is very popular within the developer community. It comes with native support for multiple programming languages and GitHub Copilot. The Copilot functionality is implemented with two extensions available in the catalog, GitHub Copilot and GitHub Copilot Chat. While the installation process is straightforward and won't be covered here, using Copilot requires a GitHub account and an active Copilot subscription, with a 30-day free trial option available. Before utilizing the Copilot extension, ensure it is enabled by logging into your GitHub account. Once everything is correctly set up, you will notice a chat icon on the left toolbar of Visual Studio Code. Clicking this icon opens the chat window, allowing direct interaction with Copilot within the editor. Additionally, download the Ansible VxRail repository from GitHub to your workspace for convenient access and editing. Having the repository in your workspace not only simplifies access, but also enriches the context for Copilot, leading to more accurate and relevant results. For demonstration purposes, I will open the same sample playbook I opened earlier in the web browser. Next, I will open the chat window and interact with the Copilot. If you're unsure where to start, type help. This command provides quick help with a list of available commands and tips on interacting with and better defining the chat context with variables such as selection, editor, or file. Let's extend the chat window a bit to have more room for conversations. Suppose you have any issues understanding the sample playbooks provided by Dell. In that case, you can highlight the specific code segment you're struggling with and use the explain selection command to get a detailed explanation. You can see that the Copilot correctly understood the YAML text format and the Ansible playbook structure. However, keep in mind that due to the non-deterministic nature of large language models, the responses you receive may vary slightly each time, and occasionally hallucinations might occur. You can improve the quality of the responses by providing more context. In this case, the description we received is highly accurate and can be extremely useful for understanding how the given code samples function. As we interact with an assistant based on LLM, we are not bound to a limited set of predefined commands. You can clarify questions about anything you get in the response using a natural language. For instance, if you want to know more about YAML, you can simply ask, "What is YAML?" Again, the response we received was very accurate and helped us better understand the provided samples and related concepts. One of the best practices for code development, especially when the code will be shared with others who did not write it but are expected to modify it, is to include comments explaining how it works. We've already seen that the Copilot correctly analyzed the code, so we can ask it to add comments to the provided sample. This will help you or your colleagues quickly comprehend the code when revisiting or sharing it. You can ask in natural language, "Could you add comments to the selected code explaining how it works?" The Copilot modifies the code on the fly and returns that in the chat window. If you are satisfied with the result, you can apply the modified code block to the main editor window. We can use Copilot to enhance the code we are working on and learn more advanced Ansible concepts. Interestingly, Copilot identified a potential vulnerability in the example code, hard-coded credentials. Copilot flagged this with a warning: embedding credentials in source code risks unauthorized access. While the example code does not include specific credentials, it uses variable templates meant to be defined at runtime. The simplest way to make the sample code functional would be to modify these templates to be environment-specific, which could introduce a potential vulnerability. There should be a better way to do it. So, we can ask clarifying questions like, "Is there a better way to handle credentials in this code?" Copilot recommended using Ansible Vault, a secure solution for storing sensitive information like passwords or keys in encrypted files instead of plain text. This is very valuable because the Copilot understands advanced Ansible concepts and even provides suggestions on improvements to the code, which again is very useful from a learning perspective. Let's try then this solution on our Ansible server. First, execute the command to create the vault by copying and pasting the following: Ansible vault create credentials.iml. We are prompted to enter the encryption password twice. Once done, the new vault file will open in your default text editor. Next, copy the provided sample contents, which specify the VxRail manager IP and credentials. Replace the placeholder values with those specific to our demo environment. After updating the file, let's close the editor and try to display the contents of the YML file we've just created. As you can see, it is not a regular text file, but an encrypted Ansible Vault file. Now, let's move on to the second step, outlined by the Copilot. Remove the plain text variables from the var section and instead include the encrypted variables file using the include vars directive. A simpler way to implement these changes than manually editing is by clicking the Apply Code block button in the top left corner. We can see that the provided example didn't include the comments explaining how it works, so we can ask for it again. Note that our first attempt was unsuccessful due to a temporary network issue, but we received the expected output when trying our query again. Again, we can apply it to the main editor window using the button in the top left corner of the code block. Next, copy the generated code to a clipboard to test it on our Ansible server. We can paste it into our preferred code editor. In this instance, I'm using Nano. As you can see, it recognizes the YML format and highlights the code for better readability. Finally, let's save the file. To run a generated playbook using the Vault, we can leverage the command suggested by the Copilot. So, let's copy that and paste it into the Ansible server's terminal session. We just need to remember to modify the playbook's file name, as we used a more informative name, systeminfo.yml, and we can run the command. The command syntax includes an additional parameter, askVaultPass, which prompts for the vault password during execution, so we must enter the password when prompted. Shortly after running the command, we can see that executing the sample playbook modified by the Copilot was successful. The output shows VxRail system information returned by the VxRail API. This successful execution demonstrates that Copilot can effectively modify and enhance our Ansible automation playbooks for VxRail, because we provided the necessary context. The responses from the Copilot were also very accurate, and we didn't face hallucinations that could result in non-functional code on the Ansible server. Let's take it a step further. Since the Copilot generates the correct code, can it also detect some common errors that we can make in the code? One common error beginner Ansible users make is improper formatting of the YML playbook files. For instance, inserting an extra space at the beginning of line 10 in our code would result in an error. So, let's try that. Let's select the code in the editor and ask the Copilot if there are any errors in the selected code. Within seconds, the Copilot identifies an indentation error and provides a corrected code block, which we can apply to the editor window. Note that the Copilot suggests some topics related to our conversation that might be interesting to explore. Let's check the answer to this suggested question. How can I encrypt sensitive data in Ansible playbooks using Ansible Vault? The response includes a concise tutorial on using Ansible Vault, which is invaluable for learning and enhancing our understanding of the tasks we performed with the Copilot's assistance. The tutorial covers how to create a vault, encrypt it, view its contents, use the encrypted vault content and vault password file, and even change the password. This concludes the demo. Let's recap. We explored how GenAI-based GitHub Copilot can expedite the learning process and enhance Ansible automation playbooks specifically for Dell VxRail. We started by setting up the dev environment, then made our first steps with the Copilot, and finally used it to improve the code while learning advanced Ansible concepts. Although this demonstration featured GitHub Copilot, alternative solutions can be employed in a similar manner. For further details on utilizing Ansible for automating VxRail, please check the following website, where you will find essential links to get started with VxRail API. I hope this demonstration motivates you to explore GenAI to accelerate the development of your VxRail automation Ansible playbooks. Thanks for watching!